Welcome to the University of Minnesota, home of the Golden Gophers. We're at the MAST laboratory and I'm the director, Kathy French. MAST stands for Multi-Axial Subassemblage Testing System. And this is one of the original equipment sites as part of a collaboratory that was funded by the NSF Network on Earthquake Engineering Simulation. Come on with me and let's take a look inside. This laboratory has the capacity to test large-scale structural systems with 6 degrees of freedom control. We can test up to 1.3 million pounds in the vertical direction and 880,000 pounds in the horizontal directions. The laboratory has a capacity to test a structure that's up to nearly 30 feet tall and 400 square feet in plan, with even larger test specimens along the diagonal. When we looked into developing, creating the MAST system, we turned to MTS because we knew of their outstanding capabilities in terms of material testing and structural testing systems. And one of the key features that we were looking for is seamless control with a 6 degrees of freedom system. We have 8 actuators, and so it's over-constrained. And so MTS came up with the ability to develop a controller to control those 6 degrees of freedom, as well as warp and shear within the system. In addition, we had a concern, and that concern was if you're applying 1.3 million pounds of vertical load on a test specimen to simulate maybe the stories of a tall building on a portion of structure below, we'd have a huge amount of friction in those bearings as we tried to push them in the horizontal direction. So MTS came up with a solution, and that was the largest hydraulic bearings that they designed, in which we have very minimal friction, just a few hundred pounds. So we're able to very well control our test specimens within the system. We've tested specimens that have included some of the first of their kind, large-scale portions of core walls under 6 degrees of freedom of loading. We've tested systems for even other universities with buckling restrained braces, concrete filled tubes, and even the bases of large wind turbine towers, developing innovative systems or solutions for those purposes. Through the years, we've continued collaboration with MTS. Originally, it was designed with a ramp and hold feature, which is great for characterizing test specimens, the behavior of those test specimens. But in recent years, MTS has implemented advanced hybrid control. And with that system, you're able to physically test a portion of a structure that's integrated in a numerical simulation. So that way we're able to test structural systems or their components subjected to different types of ground motions to look at the response of those systems and the response of the entire structure. So again, welcome to MAST. We're pleased to have you visit us today.